what were we doing in the last lesson? So I thought I'd start with a little bit of revision of one of the questions we did in the last lesson. And we focused on this process of completing the square. And what completing the square basically looked like was it looked like taking an expression and creating a perfect square trinomial. And the way we did that was we looked at the number in front of the x, we divided it by 2, and then we squared it, and we got some new number. And that new number we added to the expression, and then we took it away again. And because we added it and took it away again, the original expression was still exactly the same. But it broke it up into two pieces. There was the constant term at the end. So 5 minus 4 is the same as 1. And then there was this perfect square over here. And that perfect square it happened because it was designed to happen. And so basically the way I get that is I looked above and I went, okay, there's an x there. So clearly there has to be an x. I look in front while I say, what's the sign? And it's going to be a minus. And then I know I need a 2. So give me a thumbs up if you feel like the general process for completing the square, or if there are any questions, now is a good time to ask about the process of completing the square. That was the main goal of the last lesson, just to kind of give it some, students sometimes find it a bit mystifying, but it's just a process. Okay. Now, completing the square can also be used to solve an equation. In this case, you were completing the square, but you just had an expression, right? There's no equals something. You weren't solving for x. You were just working and you were changing it to another form where you had this perfect square. But now I'm going to show you how to use completing the square to solve an equation. So what you need to do is, first of all, notice the difference, and then notice that most of the work is going to be dealing with this, and to realize that over here, this minus 12 is kind of getting in the way. So I'd like to move the minus 12 away. What should I do to move the minus 12 and make it less kind of in the neighborhood so I can focus on completing the square? Who has an idea? Transpose. Siamtanda, that is exactly what I was looking for. So basically you add 12 to both sides, or some people say like this. And what you do now is you can focus all your attention on these two variable terms. Now, if I wanted to complete the square, before, when it was an expression, I was adding a number and taking it away. It's not going to be exactly the same, but it's a similar process. So let's focus on the 6. What number do you think I'm going to add to this to complete the square? So before even worry about taking it away, what number, if you think about the process we've used so far, what number will I need to add to complete the square here? So the process is to look at the 6 and divide it by 2, but then you take that divided by 2 and you square that, which actually 6 over 2 is 3. 3 squared is 9. And now what I'm going to do is I'm going to add 9 here to complete the square with this trinomial. But in the land of equations, we're not going to add 9 and take it away again. What we're going to rather do is we're just going to add 9 to both sides so that it's basically both sides stay equal. Give me a thumbs up if you followed that. Give me a thumbs down if you didn't follow that logic. Okay. So the next thing is 12 plus 9 is 21. The whole point of this method is we're solving this equation. If you look at the key term, solve equation using completing the square. I have completed the square, and I want to know from you, what do you think goes inside the bracket here? What do you think goes inside the bracket here? So there's going to be an x, because otherwise I would never be able to expand it to get that. I look at this thing here and I know it's a plus, and then I actually just look at the number inside the square bracket here, which is 6/2, which is 3, or I can say, what number do I know when it's squared gives me 9, and I get that. Okay, but now if we're going to solve an equation, we have to get this x by itself. And the problem is there's a squared. So what undoes squaring? What gets rid of squaring? What gets rid of squaring? What's the inverse process to squaring? What's that going to be? Oh, we're going to square root. Yeah. So we square root that side, and we're going to square root this side. Now, when we square root a number, we can get positive and negative here. So it's something to watch out for, that we can get positive or negative. But that's not a problem. So I get x plus 3 equals plus minus the square root of 21. Now, square root of 21 is not a perfect square. And so what we say is it's a surd, or it's an irrational number. So it's going to give us a messy looking answer, but we don't have to worry about that yet, because the last thing we have to do is deal with the plus 3. Now, how do we deal with the plus 3? We just take away 3 from both sides, or we transpose. So that is going to be that. But what we normally do is we write the two answers separately. So we go plus square root 21, or just square root 21 minus 3, or x is minus square root 21 minus 3. I want you to put this in your calculator and give me decimal place answers for those two. So I want you to round off to 2 decimal places. So please give me the answer to that. Please give me the answer to that. So welcome to Gemma, Musalaseni, Simtanda, to Stephen, and there are a few students who are trying to get in. They seem to be having some issues, but let's see how that goes. Okay, what do we get, guys and girls? Square root 21 minus 3. I'm guessing square root of 21 is going to be like 4.5 something. So I guess it's going to be somewhere around 1.5 something. Let me know in the chat what you get. And then here, this is going to be minus 4 point something. So I guess it's going to be minus 7 point something. I'll wait for those answers. You need to use your calculator and let me know in the chat. So what do you get, Siamtanda? What do you get, Gemma? I want to know. Who has an answer for me? If I put it in my calculator, I get square root 21 minus 3. SD, I get 1.58. Oh, I was pretty close. 1.58. And then if I go minus square root 21, I go minus 3, I get minus 7.58. Give me a thumbs up if you got that. Give me a thumbs down if you didn't. I'm going to see if is everything coming through clearly. It seems a bit quiet in the... Okay, just want to check that it is working. You guys can hear me. Okay, so if we look at the process, let's just look at the process, then you're going to do one for me. Step 1 was to move the 12 to the other side. So I'll even say transpose. Step 2, okay, so that's step 1. Step 2 was to add number to both sides. to both sides, but it wasn't just any number, it was the number that completes the square. Step 3 was complete square. Step 4 was isolate x, and I used the inverse, and then step 5 was answer. So those are the 5 steps that I used. Now I want you guys to try and solve for x by completing the square in this next example, and we are going to do this one. So over to you. Tell me what you get, or how would you solve for that value of x? How would you solve for x by using the method of completing the square? And I want you to go, what is the method? How would I transpose? What number should I add to both sides? How do I complete the square? Okay. And then once you're done, I want you to say done in the chat. Once you're done, I want you to say done in the chat. So for me, that would be my first step. What is the number that I need to add to both sides? Pop that number in the chat. What number do I need to add to both sides? What do you think? Gemma, what number would you add to both sides? And Muhuluseni, what do you think? Can you remember the process? Is it going to be 6? Is it going to be 9? So this method is called completing the square. So if the teacher says solve the equation by completing the square, now most of the time you wouldn't use this. You'd probably use something called the formula, which I'm going to talk about in the second half of today. But sometimes you do need to know how to use this process, and it depends. Like you can use it inside of an expression, which we do actually when we do functions, or you can use it to solve an equation. That's called completing the square. And I think the next step is to go 6 divided by 2, and I get 3, but then I need to square that. So what is that? That's 9. So I'm going to add 9 here and add 9 there. Now, what is my number on the right-hand side going to be then? And what is my square on this side going to be? Because I know it's going to be a square. It's like... Pop your answers in the chat. Exactly, Gemma. What a wonderful number 1 is. Nice and simple. And then on this side, we have an x. Now, because the middle term has a plus sign, this will always have, and then this will have that. Now, I want you to solve for x. Get me my final answers. What is my final answers here? I think I need to do this. So I get x plus 3. Oh, sorry. X plus 3 equals plus or minus 1. And then when I split that, I get x is 1 minus 3, or x is minus 1 minus 3. So minus 2 all minus 4. Now, just to show you that this method is telling you the truth, and actually the title of today's lesson is Methods for Solving Quadratic Equations. So we're just looking at different methods we can use. Another method I could have used for this quadratic equation is I could have factorized this. And if I factorized this equation, or if I factorize the expression part, you would notice, okay, let's do this. So equals 0. If I factorize that trinomial, I actually would have got x plus 2 and x plus 4, in which case x plus 2 equals 0 or x plus 4 equals 0, in which case my final answer is minus 2 or x is minus 4. And isn't that a wonderful world? Because the answers are the same. Even though we used a different method, we could use factorizing to solve a quadratic equation. If we use this other method, completing the square, it still gives us the same answer. So at least mathematics is consistent. Now, the most common method used is something called the formula. And most students use that, but it does take a bit of work to do it. So sometimes if a question is very, very easy, we use the factorizing method. If the question says solve by completing the square, then you have to do it by completing the square. But it's most of the time you'll end up using the formula. Okay. Let's do okay, let's do this one. This is a bit more tricky. So, okay, let's say we have to solve this equation by completing the square. So I'm going to say solve this by completing the square. Now, there's one limitation or limit we really have to be careful of with completing the square, where something has to be in place before we can get it to work. What is wrong with this question at the moment that makes it very difficult for us to complete the square on this equation and solve for x? There are brownie points available for the person who spots that there is a problem here that I need to resolve before I can start completing the square. What is the problem? Coefficient is not 1. Yep, coefficient is not 1. Okay, so if I wanted to make it 1, what I would do is I could either divide through by 3 or I could do this. What do you think goes inside of this bracket? What do we think goes inside here? So I think it should be x squared minus 2x minus 3. What can I do with the 3 now to make it less of an issue? What should I do with that 3? What do you think? So I've taken out the 3. Now the good news is I now have a 1 in front, but I still got to deal with this 3. Well, I think I'm just going to take it to the other side, or transpose, and if I divide both sides by 3, that's another way of saying it. Now, what's 0 divided by 3? I think it's just going to be 0. In which case, we now have a much simpler thing. Yeah, exactly. Jem, I agree. Now, I want you to try and solve this thing, which is much easier now. I want you to solve this expression by completing the square. And see if you can get, it shouldn't be too hard, but can you solve that by completing the square? Yeah, Stephen, let's go to you. What is your question?
So I don't have a question per se, sir. Isn't on the bracket it's supposed to be x to the power of 2 minus by 2x minus by 2?
Ooh, let's have a look here. I have made a little silly error, so apologies there. So well caught out, Stephen. I don't know what happened there. It is x squared. Let me just check. Now this, you know what I did? I figured out what I did.
Yes, sir.
You see, I swapped them around. I obviously had a moment there. So let's redo this. So x squared minus 2x minus 3. Does that feel a bit more on the right plane there?
No, I know, because I'm a bit confused on it, so because if I look at it, 3 can
No,
be
no,
cascaded into all of them.
no,
So
no.
I'm
Yeah,
surprised on how you guys are 3. Because I'm thinking it's supposed to be 2.
yeah. No, no, exactly. So that's it. That was me having a moment. Um,
Thank you.
are we all comfortable now with the fact that that becomes x squared minus 2x minus 2 equals 0? It took me a while to get there. Simtanda, what do you think?
Yeah, so sir, basically, let's go back to the start.
Yeah,
So let's just say we did not take out a common factor, we instead transpose the 6 to the other side.
yeah. So
So
if you did
then
that,
it's,
it would look like this.
yes. So then basically we divide everything by 3 since we need the
Ooh, that's
coefficients to work.
interesting. So then you'd get x squared minus 2x equals 2.
Yes, so is it fine if we do that?
Perfect, because you know what's going to happen in the next step here?
Yes.
I'm going to bring the 2 across and life is good. Okay,
Um,
absolutely perfect. Yeah,
okay, thank you, sir.
cool. Now, what are we going to add to complete the square is the next question. What are we going to add to both sides to complete the square? So I take out the minus 2 and I divide it by 2, and then I need to square it. So I really focus in on that bit, and minus 2 over 2 is minus 1. Minus 1 squared is 1. So then I need to add 1 to this side and add 1 to that side. Then I know I'm going to get a perfect square here, and I know that that is going to be 3. What is going to be inside that perfect square? So I think it's going to be x minus 1. So last bit, what are my answers going to be then? If x minus 1 squared is 3, what are the final answers going to be? Now I have to square root both sides. And then I'm going to get x minus 1 is plus or minus the square root of 3. But what are my final answers as decimals? And then it's time for our halftime break. After the break, we're going to look at the more common method of doing this, but it's students really run away from completing the square, and you need to at least not be scared of it. Like you must be comfortable understanding what the process is and how we use it. So what are my answers in decimal? Plus square root 3 plus 1, or x equals minus square root 3 plus 1. But I want to know, what is that as a decimal? Let me know. Let me know. Let me know. What is the answer going to be there? Punch those numbers into your calculator. You need the experience. So square root 3 plus 1, I get 2.73, and it appears Tanda and Stephen agree, which is good news for all of us. And then minus square root 3 plus 1 equals, I hit the SD button on my calculator, x equals minus 0.73. Now, what we notice again is these are quite messy answers, but that's because this, these are decimal roots or answers to this question. Okay, nicely done. So in the first half of the lesson, we went over what it means to complete the square. We saw how to do it in an expression. We then improved, or we used completing the square to actually solve any quadratic equation, and we saw that it gives the same answer as if we had used factorizing. After the break, we are going to look at how do we use something called the formula to solve quadratic equations, and how it also gives the same and correct answers. And we'll talk about where we might use different methods in different places. But I want to now go to the most important part of the whole lesson, which is the brain break / exercise break. So I want you to turn on your cameras. I want us to see each other and realize that we're all together when we are jumping and stretching and doing all the good things. And so please, if you could just turn on your cameras and make sure that you are with me as we take a break. And I know some of you probably have had a long day, and I sympathize with you because I know you're like, why are you making me stand up? Why are you making me turn my camera on? But we just know from learning science that if we take care of our bodies, if we feel socially connected, if we do certain things, we learn better. And even if it feels uncomfortable, that's part of the job of learning. Okay. So Stephen, Simtanda, Gemma, Mussolini, Arsen, let's see those cameras on, and I want to see you standing up and breathing. Two more deep breaths. Last one. Okay, so you've got oxygen in your body. Now I want you to shake up your arm a little bit. So just shake it around, shake up this arm, get nice and loose, like you're dancing or whatever. Then shake up your legs. You really want your body to feel nice and relaxed, like you've been sitting for half an hour, you've been thinking hard, your brain's been stressed. You want to tell your brain, look, brain, you can relax. Okay, then let's just roll our shoulders. So we'll roll our shoulders back. If your shoulders are tight, just breathe in, just relax. Okay, then roll your shoulders forward. Okay, arms out, small circles with your arms. So small circles. I can feel my body relaxing literally as I'm doing this. And then change direction. Now I can feel my triceps working. Okay, then one more last shake. So your body really knows it's unwinding. There's no need to feel tight or stressed. We're just loosening up. And we want our bloodstream to circulate. So we're going to make blood pump with some jumping jacks. We're going to do 15 jumping jack just like this. And let's do 15 quality jumping jacks in 3, 2, 1. Let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, I definitely know the blood was pumping in my body, but I also know I feel like my brain literally, I feel like I'm twice the maths teacher now that I'm back with you, because my brain feels like it's had a chance to unwind. It doesn't feel like it's been here all day. which is the goal for you as well. So here is the puzzle. Can you solve this this puzzle problem thing for a bit of fun before we do the next little bit? Okay. So, Stephen, you know your fractions. The key to this one is to go -3 divided by 1/3 plus 2. And then if you do that, what you want to do is you want to deal with this dividing part. So you go 9 minus 3/1 times, and you tip in times, that becomes 3/1 plus 2. Then this becomes 9 minus 3 times 3, which is 9 plus 2. And so then the final answer is indeed 2. But it's tricky because of the BODMAS thing here. So that is part of the thing here. All right, let's go back to, I hope that, how do you feel? Just give me an emoticon. Do you feel like the break made your energy? I mean, it's the end of the day, so I understand you're tired, but do you feel like you're a little bit, like it reset your concentration span, or did you feel like, no, it made no difference? I'm curious to know, as someone who thinks about learning and things like that deeply. I thought so, yeah. I mean, it doesn't always, sometimes I feel irritable and I'm like, I don't want to do it. But there's something about our brains when they relax, they just suddenly, you get a last bit of concentration. Okay, so let's talk about what's called the standard form for a quadratic equation. Every single quadratic equation can be written in the form ax squared plus bx plus c. Let's have a look at the one that we just did now. In fact, let me bring it down and we can compare. What was the one we just did now? It was that one. Okay, so let me go bring that down, Control C and Control V. I want you to look at that and tell me, if I'm talking about something called the standard form, what is A in the scenario over here? What is B? What is C? So you look at this example that we've just done, and if you think about the standard form as that, what is A, B, and C? And I want you to put that in the chat. Okay, so I think, oh, sorry, Stephen, I'm not referring to, okay, so in this case, we don't know what they are. I was kind of referring to this one over here, this bit over here, and this bit over here. So A in this case would be 3, if I'm referring to this example. B would be -6, and C would be -6 as well. Okay, so often, if we're going to use this thing called the formula, which is the tool I'm going to show you, it has to first be in standard form. And then what you need to do is write down the values for that equation of A, B, and C, and you start to use them. Okay, so what is the quadratic formula? So the quadratic formula actually just takes this standard thing. So the standard form is ax squared plus bx plus c equals 0, and it applies completing the square. And by using the completing the square process, we get to this formula over here. So x equals minus b plus minus the square root of b squared minus 4c over 2a. Now, what an absolute mouthful. But in reality, it's not that hard to use because you have just told me that a was 3. You can see in our question there, b is minus 6 and c is minus 6. So if I was going to apply it to this formula, all I would do is I would go minus something plus minus something squared minus 4 something something over 2 times something. And then I'd look at my list and go, well, that's an A, so it must be 3. This is a minus 6, so that must be minus 6. That must be minus 6. What is the 4A? The 4A, A was 3. And what is C? C is minus 6. So all the formula requires you to do is to take the A, B, and C value and plug that in. But then you have to do some cleaning up. So you will go minus minus 6 is 6, plus minus, and we'll leave that. And then below that is 6. Now, this thing inside of the quadratic formula, b squared minus 4ac, it has its own special name. It's called delta, and it comes up in the topic nature of roots, because once you know what delta is, you actually know the nature of the roots of the equation. You don't even have to go any further. But if you want to find the roots, you have to then finish off the quadratic formula like we're doing. So can you work out for me what is delta, or what is this thing inside the square root for this particular question for me? Find me what delta is. And I want everyone to put this in the chat because this is important. It's really important. Okay, so inside of this, to get what delta is, minus 6 squared is 36. Minus 4 times 3 times minus 6. Let me just check that. So minus 4 times 3 times minus 6 is 72, but it's plus 72. And so x is going to be 6 plus minus 108 over 6. Now, 108 is not a perfect square, so delta is not a perfect square. And so when delta is not a perfect square, it's going to mean that the square root is an irrational number, and we get like messy answers. So we're going to get x is equal to something, so 6 plus square root 108 over 6, or x is 6 minus square root 1 over 8 over 6. And this is why the nature of the root section, which we do later, the moment you know if delta was a perfect square, then our roots would actually be, they wouldn't be messy, they'd be rational. But the moment delta is not a perfect square, the answers come out as messy decimals. So I want to know what is my two answers for x using the formula. Pop them in your calculator and tell me what they are. So what do we have? We have 6 plus square root 108 divided by 6. And I get, let's see if anybody else gets what I get. I get minus 0.096, which actually is going to round up to 0.10. And then on the other side, 6 minus square root 108 divided by 6 is minus 0.73. Can we just check if anybody is, how we're going on that? So I don't think I made a mistake here. 6 plus square root 108 divided by 6, 6 minus square root 108. I want to see, does anybody else get what I'm getting? Put your answers in the chat, please, people of grade 11S. Come on, everyone. I need to see if you agree or disagree with me. Are you getting the same answer as me? Giving different answers. Interesting. Okay, let's just see if I made a silly mistake, but I don't think I have. So we said A is 3, B is minus 6. There's my minus 6. Minus 6 is... Okay, let me try again. Maybe I'm doing something wrong here. Square root 108, and then I get plus 6, and then I get divided by 6. Oh my goodness, I'm making mistakes. Sorry, guys. It is in fact 2.73. And what is my other answer? So obviously my calculator did something weird. 6 minus square root 108. And then divided by 6, I get... Did anybody get minus 0.73? Okay, ladies and gentlemen, we have got our answers. This is a good feeling, isn't it? Now, didn't we? So we have done this formula. Now, this question that we just did, we actually did it in another method earlier in the lesson. So if I'm really telling you the truth, we should find our answers are the same as what we did if we did it earlier. Let me actually put this in a yellow color so that it is easier to read. So we know that we got 2.73 and we know we got minus 0.73. Let's see what we got earlier in the lesson. So the good news is earlier in the lesson when we used completing the square, we got the same answer, which means that all is well with the world. Now, as you practice these questions, you'll decide which one is easier and which one isn't. Most students do like the formula and they start to get used to it. And so to end today, I just want us to practice applying the quadratic formula to help us learn how to get good at solving quadratic equations. So I will leave up the working out that I did earlier on the board. So let's just put that there. And I want everyone to try and solve this quadratic equation for me. And when you are done, I want you to say done in the chat. If you can't remember what the formula looks like, you're probably not alone. The quadratic formula looks like this. So first you write down what A, B, and C is, and then I want you to plug it in, and then I want you to see what answers you get. Okay, question. Siamtanda, what is your question?
So, sir, basically from this, what you call, from the standard form, ax
Yeah.
squared plus bx plus c is
Yes.
equal to 0. Can't we use it
So
to find what you call? Can't we calculate to find the quadratic formula?
Okay, so are you okay, Simtanda, with A being 2, B is 5, and C is -4? Are you okay with that?
Yes. Yes.
So now what I'm going to do, all we're doing today is we're applying the quadratic formula. I'm not showing you why it works. That's a separate idea. I have to show you the whole completing the square process. So all we're doing today is what is going to go inside that first bit.
Yes.
So what do you think goes here? It must be whatever B is, and B was 5.
Yes.
And then the same thing over here. Then I have to decide what goes here and here. And in the formula, it was A. Now, what is A? A is 2, so I put a 2 there. And then for C, what do I have? I have -4, so it's -4. Okay, so, and the bottom, what are you going to have on the bottom here?
2 multiplied by 2.
5? Oh, 2, 2A. I'm making boobies today. 2 times 2, exactly. So then we have -5 plus minus whatever that works out, what delta works out to be, over 4. So let's just check everyone gets the same delta value. What is the value of delta inside your square root? What do we get inside there?
$57, sir.
All right. Can anybody confirm 57? So I definitely see 25. 4 times 2 is 8. 8 times 4 is 32. So I am with you. Yep. So now we have x is -5 plus minus the square root of 57 over 4. What are my final answers going to be for x? What are my final answers going to be for x?
The first one is going to be
Yeah.
x equals to 0.64.
Say it out loud. I'll check in a moment, but what are you saying it is?
0.64.
All right, let's just check with the clock, okay? And what is your second one going to be? And I'll check you in a moment.
Negative 3.14.
Negative 3.14. Okay, let me check. So -5 plus square root 57 over 4, or x is -5 minus square root 57 over 4. So my calculator says -5 plus square root 57, that's divided by 4, and I get I get 0.64, so I completely agree with you there. And then on the other side, I have -5 minus 57, square root 57, and I get divided by 4, and I get -3.14. So that's perfect. All right, everyone, what have we done today? We reviewed completing the square, the process for just expressions. We then looked and saw that actually we can solve a quadratic equation by using completing the square. We also looked at an example where we used factorizing to solve a quadratic equation. And then the last 20 minutes of the lesson has been introducing this new tool called the quadratic formula. And this quadratic formula makes use of A, B, and C. And the A, B, and C come from the standard form of a quadratic equation. So the quadratic equation looks like this. And so whenever you are going to use the formula, you first need to make sure that you have your quadratic equation in this form. Then once you have the numbers a, b, and c, you can simply put them into the quadratic formula. Inside the quadratic formula is something called delta, which is the bit inside the square root bracket. And the moment you know what delta is, you kind of know quite a lot about what the final roots will be. And that is it for today. So